Good afternoon, everybody. How are you doing today? So my name is Henry Brown. I'm a manager for Global Support Services, and I'm here to welcome you to this session on performance best practices and troubleshooting. It's one of our more popular sessions for our VMware Global Support Services support days. Just a quick show of hands. Has anybody been to a support day in any of the cities that we travel to across the United States? Okay, thank you. What I'd like to do now is introduce to you your speaker. His name is Jake McDermott. Jake is one of our support account managers out of the Denver, Colorado Center. Let's give him a warm welcome and welcome, Jake.
All right. Well, good afternoon, everyone, and welcome to the last day of VMworld. I hope that everybody in this room has had, quite an experience here, learned a lot. What I'm going to do is I'm going to try to impart upon you some performance best practices, tricks and tips that have kind of borne themselves out through our VMware customer support centers. So a lot of the content that we'll cover today is actually covered in our customer support days. But a lot of this information is also part of me discussing with some of our senior technical engineers what they see on a day-to-day basis, some of the issues that they encounter. So without further ado, I'll go ahead and I'll get into the meat of it. So in our customer support centers, one of the things we'll commonly hear is, my VM is running slow, I don't know what to do, or I tried adding more memory or more CPUs and that didn't work. So this is pretty much an indicator when we're running into a performance bottleneck, and I'm sure everybody in this room at some point in time has had to deal with something like this. So real quick, this is kind of what we're going to go over. I'm going to spend a little bit of time on benchmarking and tools. It's my philosophy that I can't have a discussion about performance best practices and troubleshooting if I don't spend some time on this and give you, just a little bit of background information and a couple tools that will help you determine if you're really having a performance issue and when you need to stop. We'll cover memory, CPU, storage, and network. That's basically the big four. So benchmarking tools is the first thing that we'll get into. And one of the things I wanted to bring attention to is in the performance troubleshooting guide for vSphere 4.1, Cheeth and Kumar and Hal Rosenberg wrote this document. And they had a great statement in there about performance. And I'll just repeat it here. A performance troubleshooting methodology must provide guidance on how to find the root cause of the observed performance symptoms and how to fix that cause once it's found. To do that, it must answer the following questions. Now, there's 6 questions there, and I have underlined it, bold, and if I could make it flash, I would. But the top one is, how do we know when we're done? How have we determined when, we've gotten past our performance problem and now we're just tuning at this point? Do we want to go further? How much further do we think we can go? So we're going to talk about that for just a couple minutes before we get into the technical side of this. So when you're troubleshooting for performance purposes, it's going to be extremely helpful to basically have a mutually agreed upon base level of acceptable performance. And this is something that not only you would discuss at the technical level, but you would also discuss at the business level to try and figure out before that application or that VM is put into production about what sort of performance you're expecting and what sort of performance is accepted. What are you looking for? What's your ultimate goal here? So there's a couple things that I would like to impart upon you, just some points here to kind of help you along that journey there. So in doing this, it's useful to use basically your benchmarking tools to generate a good baseline of performance prior to any sort of deployment. So before you got this into production, you know what it's going to look like on paper. And if it's appropriate, run those benchmarking tools on physical hardware first, then arrive at your base level of performance, and then only then take that into your virtualized environment. Because at that point, you're going to be able to say, okay, well, this is how it performed on physical servers. When I go to a virtual environment, I'm expecting near physical, or maybe even sometimes better. But if I get inherently much, much worse, then I know I'm running into a problem. I've got that baseline that I can work off of. One other thing I would say, and then we run into this a bit in support, is try to stay clear of metrics that are subjective. And when I say they're subjective, it could be because it's due to an issue on the client side. It could be that we're clicking a button inside of a web submission form. And that particular button, it goes back to the server and it does a whole bunch of computation. And then it spits out the result, but it gives it to the user's computer. Their browser has to process it, then it has to open up an external viewer, and then it has to render everything. And by the time it actually gets to their eyes, from the time it was sent to their workstation, you could potentially be running into a subjective performance issue. So try to stay clear of something like that if you can. Along that same line, so benchmarking can also be accomplished at your application layer, obviously. But I would say you need to be aware of just a couple things here. So in situations where we have human interaction, such as that aforementioned, web page where we have to, wait for something to come back to us, or even better, a web page that needs to be filled out. They need to click a button, wait for a result, and then click another button or fill out more forms. Utilize third-party automation tools or macro applications where possible in order to minimize the amount of subjective information that you're getting as part of that benchmark. The other thing I would say is if you're going to be using in-VM benchmarking tools, it doesn't really matter what they are, but if you haven't already had a conversation with the vendor of that tool, I would recommend just sending them a quick email and say, hey, I haven't seen it in your documentation, I've checked all over the place. Is your application virtualization aware? Is it aware that it's actually going to be descheduled inside of the ESX host? It's a good thing to know because if you have an application that is not virtualization aware, you run it, you get results that don't look very good, you could actually be on a wild goose chase. You could actually have an application that's giving you false data. The other thing I would say is don't run your benchmarking on a host that already has other workloads on it. And this is taking a test machine and dropping it into an environment where there's already production workloads. We could get a false reading on what the application performance of that application should be versus what it could be in kind of a best case scenario where it's getting all the resources it needs, it's not contending with other VMs. So as with running it on physical hardware first and then applying it to virtualization, I would also say take your application or take your VM, deploy it in a test environment first, get your best case data there, and then take it into production. So one of the other ways that we can monitor for performance, and this is fairly new, is vCenter Operations. And vCenter Operations it's a product offering from VMware that allows you to a much, much greater degree than you can get in the vSphere client to predict, to look at your performance data, not just what's in the vSphere client, but pretty much all the counters that are in ESX top, all those advanced counters that you would like to see, but also look at it over historical basis, and also set up some alerting, some trending, get more intelligence into the performance of your applications. So if you haven't looked into vCenter Operations, I would definitely recommend doing so if you find yourself in a position where you're going, I've got all this historical information in the vSphere client, but it doesn't give me the level of depth that I would require, and I can't really build any alerting into it that's incredibly useful for what I'm trying to do. If you're at that point in your journey, I would recommend looking into this application. There are also other third-party vendors that make similar. But for the purposes of this talk today, I'm going to be talking about ESX top for the most part. I'll try to do some parallels to the vSphere graphs, but when we're talking performance troubleshooting, sometimes the vSphere graphs don't give us the level of granularity that we're looking for. Or sometimes they might not even be plain available. So ESX top has a couple advantages, and I'll cover the big two. The first is that it's going to incur very, very little overhead on the ESX host that you're actually running ESX top on. It's lightweight. Even if you use our ESX top, again, the footprint is very small. So if we are running into a situation where our performance is so bad it's affecting our connectivity to our host, then this is going to definitely help out with that because we might actually be able to connect to it using our ESX top or log in via the troubleshooting console and run it from there locally. The other thing I really like about it, and this is the big thing, and if you take this and you understand how to use ESX top and export your data into a common delineated file or an external source, when you open up an SR with VMware support, if you include this data, we're going to love you a lot for it. ESX top can be exported into a file such as a CSV or just a flat text file, and then it can be viewed offline or played back. Or you can take it into like a third-party utility such as ESX Plot, the Microsoft Performance Managers. You could, if you're crazy enough, you could even open it up in Excel if you really wanted to. So that's one of the big things for it. Now, there's a link down here at the bottom if you want to know more about ESX Top and if you want to know everything about all the counters it has. Everybody will be receiving a copy of this presentation as part of your VMworld membership. I believe they're going to be posted on Friday, so you can just go out to the VMworld website and download this presentation. But if you want, go ahead and copy that link down now. It's a pretty good document. It's written by our community members, and I would definitely recommend it for anybody who is either passingly familiar with ESX Top, down to those who are even using ESX Top on a daily basis, because they may cover something that you don't know. So I'll go ahead and I'll get into the meat of the presentation here. So the first part that we have here is memory. And, memory is one of those that we do get quite a few calls on it anymore in support, so I, do want to spend a little bit of time on it. So when we're talking memory, what we're really talking about is the physical amount of RAM that's allocated to a VM. But what we're really doing is we're telling ESX how much physical memory or even virtual memory a given VM process is going to maximally consume beyond the overhead of that VM. So the overhead being what's required to keep that VM even virtualized. It can be about 200 megabytes. It could be even more depending upon the configuration of the VM. So whether or not that memory is physical or if it's virtual is going to depend on a few factors. So the first part of this is the host configuration. This is the obvious one. How much RAM do you have in your host? Do you have 16 gigabytes of RAM? Do you have 96, 128? How much do you have? The other one is DRS shares and DRS limits. Now these two, DRS shares are a way to influence how much a VM will win contests for contended resources. And then a limit says anything beyond that limit is going to be virtual memory. It's going to be swapped. There's no question about it. Reservations are another way that you can influence whether you're going to get physical RAM or you're going to get virtual RAM. Reservation is the opposite of a limit. A reservation is I'm telling ESX that this VM should always get this amount of physical RAM when it requests it. It's not permanently allocated to that VM. We can give it to other VMs, but if that VM requires it, it's going to get it back through the use of ballooning. It's guaranteed. Also, host load is another way that we could potentially influence whether we're getting physical memory or we're getting virtual memory. That one's pretty obvious. How many VMs do you have running on your host at any given time could definitely influence, whether you're able to cover the active memory requirements of all your VMs. DRS would be one way of balancing that out. If you've got a lopsided host and you don't have DRS running, well, there's no way for those VMs to get off of there. So there's one key takeaway in the memory section of this presentation, and that is storage bandwidth, or swapping, is always, 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 always more expensive, time-wise, than memory bandwidth. So anything you can do to prevent your VMs from going to physical disk to get their memory is going to lead to better performance. So in general terms, it's going to be better to overcommit than it is to undercommit. If our running set of VMs are going to consume too much host memory, so they simply just can't fit on the host that they're on, they've got too much memory configured for them and they're using all of it, then what we're going to run into is some VMs, they're not going to get enough physical host memory. And what this can lead to is it could lead to forced ballooning, so we're having to page out hot pages instead of cold pages. It could lead to greater disk usage as all of those VMs start to swap pages out to their vswap files. This results in what I would call storage drain. The idea is that all of your VMs, and even any attached physical servers that you might have, start to slow down as a result of the increased disk traffic going out to your SAN, because all these VMs are now pulling memory out of their vswap files. They're going to your SAN to get their memory. So now regular IOs are having to contend with memory IOs out to that SAN, and it slows everybody down. And depending upon your SAN, this could even be your physical servers getting the slowdown as well. So the opposite is also true, that if we don't size a VM properly, if we give a VM too little amount of RAM, we give that Windows XP VM only 128 megabytes of RAM, which we know is not going to be enough. So within that VM, what we start to see is we start to see in-VM page file swapping start to occur. And that also results in disk traffic. And again, we get the same slowdown. All of our VMs, even our attached physical servers, may slow down for that increased disk traffic. The one thing I would caution everybody against is if you're going through this journey, if you're trying to figure out, well, what's right for me, don't make your memory footprints too big. There's nothing to prevent you from giving that theoretical Windows XP machine 8 gigabytes of RAM, 16 gigabytes of RAM, however much you want to give it. We're not going to prevent you from doing that. However, I would caution you that when you do that, you introduce higher overhead because it costs more to keep that VM up and running. HA complexities, potentially that VM consumes more HA slot sizes than it would normally. And also can be a little bit wasteful. If you've got a VM that is using memory that it doesn't really need to, then you might have to put more RAM in your servers, and that might not even be something that you even had to go there. So in this case, what do you do? So the bottom line here is to avoid high active host memory overcommitment. So your total memory demand on your ESX host is a sum of the active memory sets of all VMs, so percent ACTV or memory active in the vSphere client, plus the memory overhead, so the memory that's required to keep that VM even virtualized, minus the page sharing of similar VMs. So this is a reference to transparent page sharing, where if we have similar VMs or we have a group of similar VMs, there are identical pages in memory that we can actually just insert a pointer to, and instead of keeping 20 copies of the same page, we only keep one. The rest are all small pointers. So in that sense, if we have an ESX host whose total active host memory commitment is less than the physical amount of RAM, there's going to be no ESX swapping. We're not going to drain our storage. Discounting limits. So if you have a limit set, you could potentially run into a problem, and there might be situations where ballooning occurs just to keep things under balance. So right-size your guest memory. Define adequate guest memory to avoid that in-guest swapping. So, and keep in mind, your per VM memory space, again, is going to overhead's going to grow the more memory that you give your VMs. I would also say, and this is a big caution, because I have a few customers who have run into this as well, don't size your VMs strictly to the average of memory active, unless you are absolutely, positively, 100% sure that this VM never encounters a peak load usage. A good example would be View VMs, where people log in at 8 o'clock in the morning, they log out at 5 o'clock at night. That generates a usage spike, it generates a memory spike, and if we don't have enough in-guest memory to cover those spikes, what do? We start paging out to disk. So ESX needs to balance the memory usage for all of its worlds. And a world can be a number of different things. It can be a virtual machine, it can be a service console, it could be VM kernel, it could be any sort of other helper world. It's going to be able to manage its memory using a number of methods. And I'll cover a few of those here. These are pretty much just for VMs. So this list here is, in order from top to bottom, most desirable to least desirable in terms of how it manages memory. So the first one is page sharing. Page sharing is easy. If we have duplicate pages in memory, we can keep one page of that, one copy of it, and give everybody else just a pointer file to that page in memory. We save memory for like virtual machines. View environments, again, would be a big benefactor of this particular technology because you're running all Windows XP or all Windows 7, all the same sort of configuration. You're going to have tons of identical pages in memory. The next one is ballooning. And ballooning, basically the idea behind it is when a VM boots up, it's going to use all of its memory. And after a while, after things have settled down, it's not going to be needing all of that memory. That memory is just going to be sitting there allocated to the VM process, but not actively used. So if we have a situation where all of a sudden we're contended from memory, we got more load on the other VMs on that ESX host, and all of a sudden we need to reclaim more physical memory because we don't have enough free physical memory to cover the needs of the VMs, we can use ballooning, which basically asks the VM, hey, do you have any cold pages that you're not using that you might be able to give back to me, or just kind of swap it out to your disk real quick and then give me the cold page that you're not going to hit very often? And then we'll give that memory out to our other VM. Compression is new for ESX 4.1 and 5.0. The idea behind memory compression is that compared to disk, it's actually less expensive time-wise to compress memory on the fly to try and reclaim some physical memory. So we're compressing memory, giving that free memory back, and then when we need that cold page, we uncompress it. So it's a technique that gives us kind of another out to using our SAN for our memory storage needs. There's one that I don't have on here that I'd like to cover, and that is new for vSphere 5, and that's called SSD swap. So vSphere 5 has the ability to, if you have it configured and you have the hardware, take your swap files and place them on an SSD drive. So now no longer are you going to go and hit your SAN, you'll actually be hitting this SSD drive. Now, it's not as fast as your memory, which is in terms of nanoseconds, but it's certainly going to be faster than your SAN, which could be in the single digits or low double digits of milliseconds. So if you've got the ability to do that, if you've got the ability to spend the money for the SSD drives, if you're already on vSphere 5, maybe take a look at that. If you find yourself in a position where your environment is almost always overcommitted on memory, you see ballooning happening or you see swapping happening on a regular basis. So the last one of these is host swapping. And this is our basic page file swapping. We're out of options. We've got to cover our memory needs somehow. So we're going to end up going out to the physical disk on your SAN in order to get that memory. This is the least desirable of all of these. The access times in terms of speed is an order of magnitude different than going out to your physical memory or going out to that SSD drive or doing compression. And as I said before, again, lack of host memory or lack of VM memory can cause systemic slowness. So just be aware of that. So the bottom line here, obviously, one of the things I've heard is, well, ballooning is a bad thing. We don't want to balloon. If I see ballooning, that's a bad thing. Well, not really. Ballooning is vastly preferable to swapping. The guest is able to surrender unused or free pages through the use of VM tools. It's going to give us the ability to use cold pages in memory versus hot pages. You may see ballooning occur even when there's no memory pressure, just to keep proportions under control. But the idea here is that if a VM isn't actively using memory, if it has all of that memory allocated but it's all in cold pages, then probably we can get some of that back with a small performance penalty in the long term. And in the near term, we're able to satisfy the needs of a VM who may more immediately need that particular memory. One thing I do want to cover, and this is a question that we get in support quite often actually, is why does my memory granted never decrease? It's always at 100%. I don't understand that. Isn't the balloon driver working? Well, yes, the balloon driver is probably working, but most VMs are going to consume 100% of that physical memory configuration when they're booting. And unless there's pressure, it is more efficient and architecturally inexpensive to keep that memory allocated to the process than it is to deallocate and reallocate that memory on demand. So what we're doing here is we're giving that VM as much memory as it needs on startup, and unless we have pressure, unless we have contention for memory, we're not going to request it back because it's actually a performance benefit to you in order to have that VM with allocated memory already. One of the other ways that we can work and get better performance out of our memory sides of things is hardware MMU or HWMMU. So prior to that technology, we used what was called shadow paging or software MMU. The idea behind this is that for all the memory transforms, for all the memory changes, the memory mapping, everything to do with memory inside of that VM, it was all done in software beforehand. And then through cooperation with hardware vendors such as Intel and AMD, we actually got the ability to do this memory mapping and this memory transforms in hardware where it's much, much faster and consumes less system overhead time. So it leads to better density. One of the questions I'll get is, well, I'm going to use hardware MMU, but what monitor mode should I use? The answer is, I'm not going to have an answer for you. The answer is, it depends. It depends on your workload. There is, again, another link there at the bottom that if you want to copy it down or check it out on Friday when you've got access to all of these presentations, go and take a look at that. It's quite a read, but the bottom line is it will tell you what the different monitor modes will do, but depending upon your workload, the best approach is to test it out, try another monitor mode, test it out, do your benchmarking, figure out which one works best for that particular load if you think that you have a problem using the default MMU stance. So some of the common performance issues that we see, again, using software MMU is, one of the big problems, especially for memory-intensive workloads, such as a database server or any sort of data mining. Anything that does a fast amount of memory transforms or, has a large amount of memory that it needs to access all over the place. Depending upon your implementation, you could potentially get about 20% performance improvement, assuming you're on the NetHLM processors or better and that you have it turned on. The other thing is we see not monitoring for ballooning or swapping at the host level. Ballooning is an early warning sign that you may start to get paging, so you may start to go out to those vswap files. If you see it, then just kind of take a look and make sure that you're not swapping on a regular basis, because swapping is a performance issue if we see it over an extended period. To look for swapping in ESX top, you can look at SWW or SWR, so swap read and swap write. Also, not monitoring for swapping at the guest level. If our VM is undersized, Windows is going to constantly be paging out to that in-guest page file. And we want to make sure that we have just kind of a bearing on how much it's doing that, because if it's constantly having to go out to that page file, again, it's generating more traffic on your SAN, and it's ultimately leading towards worse performance. Removing the balloon driver or disabling or marginalizing transparent page sharing would be another one. When I say marginalizing TPS, I'm more referring to you have a very large cluster with a disparate group of VMs that may or may not be very similar, if at all. If you've got the ability to do so, both from the business perspective and the technical perspective, to group like VMs together inside of your clusters, that's probably a good approach if you think that you're memory constrained and you want to take full advantage of transparent page sharing. Also, undersizing your VMs for peak loads. Again, it's that 8 o'clock in the morning and the 5 o'clock at night log in, log out problem. Or if you're doing processing at a certain time of night, just make sure that if you're looking at memory active, you're not only looking at the average, but you're taking a look at the peaks to make sure that you're covered there. Okay, well, the next section is CPU. And CPU is definitely one that there have been some great strides made in the last few years, definitely with vSphere 4, 4.1, and now 5.0 coming out. As you know, we went from a maximum of 8 vCPUs in vSphere 4 to 32 in vSphere 5. And that's just due to how we're improving the scheduler as time goes on, coupled with cooperation from our OEMs. So basically, CPU resources are the raw processing speed of a given host or given VM. However, on a more abstract level, what we're really trying to do is we're trying to schedule those resources. So every VM that has a vCPU that needs to run, we need to make sure that we've got a physical CPU in which to run that. We also have to account for running that VM in the most optimal fashion. That typically means we're going to be running it on the same processor that VM last executed on. And we do that to take advantage of the L1 and the L2 caches, and these days the last level cache that you'll find in multi-core processors. So in ESX top, it's pretty easy to observe the percentage of the CPU that's used for a particular VM. But that particular metric is actually a sum of 3 different metrics. So percent used, or CPU used, is a combination of run, which is the total amount of scheduled time that VM is scheduled to run, plus sys, which is your system overhead for that particular VM. So this would be servicing drivers, servicing the interrupt for those drivers, doing privileged instructions such as like a system get time date call, that sort of thing. Minus the overlap. And overlap is the amount of time that we're spending on behalf of another virtual world. So we're held up by some operation inside of another virtual world. So one thing to remember with CPU is that different workloads can easily present entirely different virtualization overhead costs, or that sys cost, even at the same utilization in CPU. This basically refers to how difficult is the workload. As you're starting out in your journey, you're virtualizing DNS servers, you're virtualizing file servers. Easy stuff, right? This stuff is all I/O bound. It's not processor bound. You can be running at 20% processor, and it's just all I/O. Again, web servers, file servers, anything that's in the non-kernel ring, definitely would fall into this category. And you're going to get little or no overhead for those loads. Something that you might get a large overhead for would be anything that has to use privilege instructions, such as an email gateway with virus scanning that uses SSE 4.1. It uses that pattern matching that's part of that. Or a SSL gateway or load balancer that has to do some pretty significant computational work in order to do the encryption. So those sort of things can generate a lot of system overhead. But generally, what we see in support that generates the most amount of overhead, that is most impactful to your ultimate density goals, is servicing non-para-virtualized adapters, virtual hardware, and sometimes even software. Because we're having to service all these interrupts, or we're having to make just a ton of privileged system calls that a non-virtualized application would know not to make, or would know to make it in a different fashion. So as you're aware, ESX4 can support up to 8 virtual processors inside of a VM. And with vSphere 5, that's now 32. So quite a big difference there. And ESX3, could not support as many, and in fact, scheduling those was even more difficult. So what makes an SMP VM even possible to schedule up on an efficient basis is what we call the relaxed co-scheduler. This basically allows a VM to run out of sync. So for purposes of demonstration, I only have 2 ARMs, so I'm going to go with 2 vCPUs. But in ESX3 and 3.5, we had to run each of those CPUs up at the same time. So we had to find 2 physical processors to run the CPU on at the same time. With ESX4 and above, we have what's called relaxed co-scheduling. The idea is that we can run one of those processors up and up and up and leave this other processor back here, basically back in time. But at some point, we actually have to catch that other processor up. And that's what's called co-stop, or CSTP. The idea here is that with an SMP VM, you're going to get the most benefit out of them if you have symmetric processing. So if you have an application that multi-threads itself out and balances itself out across all of the processors in the VM. Because if we have an unused CPU, we're going to waste our system resources. We're going to impose some unnecessary scheduling constraints on the ESX server, especially with what we call, again, co-stop. Co-stop is a measure of how often we have to catch those virtual processors up. And in order to do so, we have to run all of them at the same time, or a vast majority of them at the same time in ESX5, because we relaxed it even further. So when you're looking at ESX top for a SMP VM, take a look at that co-stop counter and just make sure that you're not seeing a large percentage of it, because if you are, that's an indicator, not the be-all, but it's an indicator that you may have an unbalanced workload. So the next thing I'm going to get into is CPU ready time. And quick show of hands, who here knows all about CPU ready time? Okay, I only see a couple hands out there. So this is a really common issue that we see in VMware support. So what is it? CPU ready time is the percentage of time that a VM is ready to run, but there's no physical processor on which to run it. They're all busy, they're all scheduled, they're all doing something else. We're having problems scheduling these VMs. And if we see a high ready time, that's exactly what it means. We have possible contention for CPU scheduling amongst the VMs that are on a host. So I've got kind of an animation that shows what CPU ready time is. It's very simplistic, and it doesn't take into account the relaxed co-scheduler that's part of ESX4. This would be more appropriate for ESX3 or ESX3.5, but it kind of gets the idea across. So here's our theoretical ESX host. It's an 8-processor host, and we have a grand total of 3 VMs that are running on it. We have, all of them are SMP VMs. We have 1 4 vCPU and 2 CPU VMs, for a total of 8 virtual CPUs. So this is pretty easy to schedule. All we have to do is we load up the scheduler, we find a free processor, we run our VM on that processor. Life is good. All of these are going to get 100% of the resources that they need because there's no scheduling constraints. So what happens if we power on another VM? We power up another 4 vCPU VM. So in this model, because we don't have the relaxed co-scheduler and we can't deschedule a couple processors out of an SMP VM, what we're going to have to do here is we're going to have to actually deschedule our SMP VMs to make room for this new VM. And what happens in this case is, yes, we've got 2 VMs that are running right now with no contention. But we have those other 2 VMs, our 2 processor VMs that we had to deschedule. They're not running. They're not doing a thing. If they had workload that was ready to run, they would not be able to do it, and they would incur CPU ready time. So in this situation, what's the best approach? How do you get beyond this? Well, again, this is oversimplified, but the best solution here is just to right-size your VMs. Evaluate those 4 processor VMs or those large SMP VMs and say, do I really need 4 processors? Or could I make do with 2? In this case, we did our right size and we figured out, they're not using 4 processors. Let's give them 2. Grand total of 8 vCPUs now. Now all 4 of these VMs can run without any contention at all. So what causes ready time? Again, there's a couple reasons for it. CPU overcommitment is the big one. And what we typically see is we see a high ready time, CPU ready time inside of the vSphere client, coupled with a low CPU usage or low % used in ESX top. What could also cause it is workload variability. If we have, and I'm sure you've heard this term quite a bit throughout VMworld, but the noisy neighbor, the VM that's just going crazy, it's got all 4 of its processors taxed out at 100%, it's working like mad, but that's going to incur CPU time or CPU ready time on all the other VMs on that host, assuming that we're already contended for CPU resources. So one of the big questions I get, and I've been working the Genius bar for the last few days, is, well, what's a threshold for this? What should I be looking at in terms of, I should dig deeper on this? There's no fixed threshold. But typically, if you're seeing 20%, I would say that should give you cause for pause and going in there and investigating why your VM is incurring that much CPU ready time. Is it because there's too many vCPUs on the host? Could you use DRS to move them out? Could you right-size a couple VMs and get yourself a little bit more breathing room? So with multi-vCPU VMs, the one thing I do want to note is that in ESX top, if you don't expand out the VM to look at the individual vCPUs, and you just want to kind of note how much ready time that VM is incurring, look at the % ready as reported in that top level view and divide it by the number of vCPUs that you have. This also applies to % used. Any SMP VM in ESX top is going to show a potential of 100% for every single processor. So just kind of be aware of that and make sure that you do the math in your head just to figure out exactly what you're looking at. So one of the other issues that we're starting to see in support, and this is pretty brand new. I actually didn't know about this until I gave this presentation to some of my peers just to kind of get their feedback. And one of the feedback I got was, we're really seeing this issue lately. And what it's called last level cache. The idea here is that this is a shared on-die cache for multi-core CPUs. So each core inside of a CPU package has its own L1 and L2 cache, and that is dedicated to that particular core. But with a modern multi-core processor, one of the other things that we're starting to see is that they're building what's called the last level cache around all of these cores. So it's a shared cache for all of the CPUs. Now ESX, by default, it's going to try and place as many vCPUs of an SMP virtual machine into as many of those last level caches as possible. So it's going to spread out the load. It's going to take advantage that, you may run on this package this cycle, and then you'll run on this one the next one, and then, you just kind of go back and forth. It's going to try and find out, where I've got space to run this workload. But for some workloads, it's not efficient. It's just due to the usage patterns of those particular VMs. They're assuming that, they have this last level cache available, and they'll be able to take advantage of it on a shared basis. Typically what we see this in is database servers, database mining, anything that has a large amount of computational resources. I couldn't tell you for exact certain, which applications or which implementations you might actually, want to run this sort of thing. What I would say is if you're running a very intense workload and you believe that this workload is CPU bound, spin yourself off a clone, spin yourself off a test VM, and turn this setting on. See if it makes a difference, because what's going to happen is the scheduler is not only going to try and consolidate that SMP VM into one CPU package and thus, one shared LLC pool, but it's also going to default to trying to run that VM on that package more than it would otherwise. So, give it a shot. Again, I would write down the KB article on this rather than the setting and go take a look at it, because it's a living document, as with all the other documents on our KB article site. So, go and take a look and see if it works for you. So some of the common issues, CPU overallocation is definitely one that, I think I've beaten quite a bit here. But, just too many vCPUs for the ESX scheduler to keep up with. And this is evidenced by low percent use counters, high in VM counters, so, high percent ready. Simply, we just can't schedule things up. So how do you fix this? It's pretty simple. It's pretty straightforward. Migrate the VMs off the host. You could right-size your VMs to reduce the amount of vCPUs on the host. One thing I do want to cover here is that as you move along in your virtualization journey, it's more than likely at some point you're going to implement a virtualization first policy, where any new deployment is assumed that it's going to be running on virtual hardware, but at some point there has to be a justification if they want to run on physical hardware. As you get further along in the journey, I would recommend that, and even if you're just starting out in that journey, I would recommend a uniprocessor first policy, where it has to be proven to your group or to your business that a given application both needs and benefits from having more than one processor. Because if you have more than one processor that's just being wasted, it's just wasting your time. It's wasting your scheduling resources. And ultimately, it impacts your density, which increases your spend. The other thing I would say, and this is not terribly obvious, is use anti-affinity rules to keep those large VMs apart from one another. Because it is much more efficient to try to schedule, one big VM that has a lot of SMP processors in it, and a whole bunch of little smaller ones. That's easier to do. It's much, much, much harder to have a host that is just filled with 4 processor and 8 processor and 32 processor VMs. So if you can, use an anti-affinity rule to keep those big VMs apart from one another to the extent possible inside of your environment. And again, your SMP VMs may not always use those vCPUs. So, again, keep that in mind. Look at the co-stop counter on those particular VMs, and the more you see that, the more it's an indicator that your processing is unbalanced, and you should take a look at it. Another issue that we also see is accidental limits. And this is really just, somebody placed a limit on a VM for testing, or was going through and placing some limits on some hosting VMs and accidentally hit the wrong one. So if you're running into a performance issue, the first place to go look is that resources tab for your particular VM. Just make sure you don't have any accidental limits in there. Along that line is also resource pools. And I know there's a lot of people out here who use resource pools. I would caution you that if you're going to use a nested resource pool, that if you're going to impose or give resources to a child pool in your configuration, that your parent pool actually has enough resources to cover the needs of all of the children underneath it. I've seen some instances where if that's not done, it imposes an artificial limit upon the VMs that are part of those children pool because the parent pool doesn't have enough to cover. So the other portion of this, and this is more from a business standpoint, is continuing to expect the same consolidation ratios with different workloads. This is a fancy way of saying that when you are starting out in your virtualization journey, you're virtualizing the easy stuff. Your DNS servers, your web server that nobody uses, that phone VM that gets used maybe once a quarter, something like that. Easy stuff. We can virtualize this until the cows come home. We can have densities up in the hundreds of VMs per ESX host. But as you start to progress in that journey, as you start to implement your virtualization first policy, you're starting to not have any low-hanging fruit. You have more difficult VMs. You're now moving on to the departmental SQL servers. Potentially, you're going even further, and you're moving on to the enterprise SQL servers, the email servers. data mining, data archival, anything like that that requires a much, much greater amount of resources and greater scheduling capability than you had in the past. So where I would caution you here is if you have a metric inside of your business where your management or your business is holding you to X amount of density per ESX host, that you also have a policy that is a rider on top of that that says, every year or every 2 quarters, we go back, we take a look at our density numbers, we take a look at what we're virtualizing, and then we say, is this metric realistic, given the workloads that we're trying to work with right now? So just kind of get an idea that as you move along in your virtualization journey, what you're doing changes fundamentally. All right, so the next section I'm going to get into is storage. And storage is one of those sections that, I'll be honest with you, this whole presentation is one of the harder ones to give because on any of these topics, I could spend 2 hours easily talking to you about all of the nitty-gritty, getting really down and deep, but I've only got an hour on this. So with storage, this is one that you could spend all day talking about because everybody's storage is different. Everybody uses different storage. Some people use NFS, some people use iSCSI, some people use SAN. Each one of those has their own idiosyncrasies. It has their own problems. So I'm going to attempt to give you some ammunition that when you think you have a storage performance problem, these are some of the things you can look at. When you're deploying new storage, these are some of the things you might want to consider. If you want specific advice, directed, targeted advice, open up an SR with our support organization, and we could definitely talk you through your performance issues, or talk to your vendor, talk to EMC, talk to NetApp or HP if you think you've got a very specific issue. So one of the things to cover here is when we're talking storage performance issues, typically when you call up to VMware support, we're going to ask you to open up ESX Top. And we do that for a number of reasons, mostly because it allows us to get a real-time bead on what sort of storage problem you're having. And these are pretty much the main fields that we're looking at whenever we ask you to do that. So the key fields here. So kernel average, or KAVG, is the average delay from when that I/O leaves the VM kernel and it goes to the adapter. DAVG, or device average, or device latency in the vSphere client, is the average delay once that I/O leaves the adapter and it goes to the SP and we get a response back. It goes to that target and we get a response back. And then GAVG, which is the guest average latency. That's the average delay as perceived by the guest, and it is a function of the first two. For the purposes of this, we're going to really talk about that device latency because that's what we tend to see most of the time. If you see a high number on the kernel average, if you see anything above, I would say 20 milliseconds or even 15 milliseconds for KAVG, open up an SR with our support organization because this could be a number of things. It could be simply that your host is overloaded, or you could be running into an issue. There's a number of things that it could be. I'd much rather you talk to our support organization than go on about everything that it could potentially be that might not apply, because we don't see it very often. Some of the other key fields that we have is QEED, or QDepth, USD, or a percentage of that QDepth that's being used. Commands a second, fairly obvious. How many commands are you throwing at your SAN at any given time? And then megabytes read and megabytes written. So the last three are kind of used in conjunction with one another because it's much easier to service a whole bunch of small commands than it is to service a whole bunch of very large commands. And when you're in ESX Top, you can actually flip back and forth between different views. So if you wanted to view per adapter, so per HBA, per VM, you could do it, and then per disk device, so per LUN or per NAA device. So what do these mean? So if we see high DAVG numbers, it's going to indicate that something is wrong beyond the adapter of that ESX host. We could potentially have bad zoning. We could potentially just have overloaded zoning. Maybe we're throwing out all of our IOs over one HBA. We could have overutilized storage processors. So we're just, as a whole, maybe even the physical environment is throwing IOs at this SAN and one of your storage processors is overloaded. It could be that we have too few platters in the RAID set to properly service the number of IOs that we're throwing at it. We're spending so much time writing things out to the physical disk that we can't service them as fast as they're coming in. High KAVG numbers indicate an issue with the ESX host storage stack. So again, if you see this, I would much rather that you call up VMware technical support, open up an SR, and we can take a look at it, because we don't see it very often. It could just be as simple as an overload, but it could also be, some things that are much more complex than that. In either case, aborts are caused by either DAVG or KAVG exceeding 5,000 milliseconds. You can see these in varlog VM kernel, or you can actually track the aborts a second counter. Aborts and or excessive resets can often be caused by unbalanced paths out to your storage. So the key takeaway here is balance out your paths. Make sure that you're not sending all of your I.O. down one path and leaving the other path empty, not doing anything. ESX4 and above supports round robin with Alua. Definitely use it if your vendor supports it. I put a caveat in there that says do not use round robin on pseudo active arrays without Alua enabled. The reason being is Alua allows us to see what is an optimized path versus non-optimized. And in some situations where the SAN deems it necessary to call a path unoptimized because it's overutilized, it'll do that. But in specific to pseudo active arrays, it will tell you what path would have to use the partner path to get to the owning SP of a particular LUN. So we don't want to use that in a round-robin configuration because ultimately it makes things slower. So some considerations. What I would first consider, and this one is something that I see with people who are just starting their virtualization journey. They've had it for a while, and now they're thinking about purchasing a new SAN, and they want to know how to provision it. Consider providing different tiers of storage. So you could go all the way down to tier 3 for SATA-backed slow storage, so for archival purposes or something along that line, all the way up to tier 0, which would be like a fast RAID 10, a whole bunch of individual spindles that are made specifically to handle a large amount of I.O. The one thing I would caution you on, though, is be careful when you're snapshotting those VMs that sit on tier 0 or have disks that sit on tier 0. If their operating system drive is sitting on tier 3 and the VMX file is on the tier 3 storage as well, what happens is when you snapshot that VM, all of your Delta files suddenly go from having tier 1 storage to tier 3 storage, because that's where we place the Delta files. So if you have a application that has a database on the tier 0 storage, make sure that you take that VMX file, move it to your tier 0 storage, and understand that when you're snapshotting it, it's actually consuming your tier 0 storage space. I'd also consider your I.O. patterns. Should this I.O. pattern affect how you allocate your SAN's cache mechanisms for that particular LUN? Do you want to balance it more towards write? Do you want to balance it more towards read? Do you want an even balance? How do you want to manage that? In all cases, it should most certainly affect how you build out your LUN. So how many spindles you have. Do you want to get more spindles to handle more IOPS? Do you want to change the stripe size because it might make sense for the character of IOs that you're putting down the path? One thing that we're starting to see a lot of, and it tends to be with View machines for some reason, is being aware of any shared data stores that reside on one LUN or any RAID set that is shared between virtualized and non-virtualized workloads. So this boils down to, if you're expecting tier 0 performance, then do everything in your power to make sure that you are actually isolated to one particular RAID set that is built for tier 0 performance, and that you're not sharing that RAID set or potentially that service processor with any non-virtualized workloads. I've had a couple customers who ran into that problem, caused them a lot of grief. This is a really good time to get really cozy with your storage admins. If you're not currently the person who manages that, get to know them, take them out to lunch. Say, hey, I'm approaching this point in this deployment. I really need to have visibility into the SAN. I don't need to make any changes, but I at least want some sort of read-only graphing and trending ability. And then again, use path balancing where possible, either through plugins such as PowerPath or round robin and Alua if supported. Mustafa Khalil has a new book that he's put out that covers storage practices in vSphere 5. And if you go to the VMware store, you can actually get a free copy of the chapter on Alua. So if you want to know more about that, grab the free chapter. Maybe you'll like it enough and go ahead and get his book. Troubleshooting, if you can, use the para-virtualized SAS adapter inside of your VMs to reduce the overhead. This is especially important with high I/O workloads. Excessive traffic down one HBA, one switch, one SP can cause aborts. It could potentially cause data loss in extreme situations when the path becomes overloaded. So again, use round robin in conjunction with a Lua, and always be paranoid when it comes to monitoring your storage I/O. Get comfy with those storage guys. Get that read-only access into the trending capability. You can even use vCenter operations for something like this rather easily. And then for best practices, always talk to your array vendor to determine if you're following your best practices for their array. We would love to tell you and support the best practices for every single array that's out there, but quite frankly, it's your vendor who's tested it, it's your vendor who's vetted this configuration. Ask them what the appropriate fan-in ratio is, or the command queue depth, etc. Okay, real quick, I'm going to touch on network. So network in support is where we tend not to see our storage issue or our performance issues unless it's in relation to storage. So I'm going to give you just a little bit of ammunition here to talk about it. So real quick, a note regarding load balancing in ESX. With the exception of IP hash, all of your load balancing options are simply ways to influence what physical NIC a VM is assigned to use as its uplink. Port ID uses the virtual port ID as a value in a pseudo-random calculation to determine that uplink. And until an event occurs that forces a re-election, so like a physical NIC state change, adding or removing a physical NIC from a team, those VMs will stay on their elected uplink. They will not move. IP hash is one way that you can get more equitable load balancing, but it's best used in situations where you're talking to a large amount of IPs. So web servers, file servers, print servers, anything that has a large amount of IPs out there, definitely set yourself up an Ether channel and use IP hash. Troubleshooting, definitely be sure to check the counters for both vSwitch and per VM. Again, this is the noisy neighbor problem. There could potentially be another VM that's experiencing high network load on the same uplink as the VM that's having the connection speed issue. 10 gigabit NICs, we're starting to see a lot more of them lately. Definitely incur a significant CPU load when they're running at 100%. So anything you can do to reduce that is going to help you out. Using TCP segmentation offload in conjunction with the para-virtualized hardware can help out, and definitely make sure you're running the latest drivers for your NIC. VMs without para-virtualized adapters can cause excessive CPU usage when under high loads, so use that VMXNet 3 driver where you can. And consider using intra-vSwitch communications and DRS affinity rules for VM pairs, such as a database with a web front end. When you do this, it will allow that VM to communicate over bus speed versus having to go out to the network. ESX 4.1 includes the ability to use network shares. This is ideal for blade systems where we've only got a couple 10 gigabit NICs. So it's becoming common. If you haven't looked into it, definitely give it a look. That way you can ensure that no one service stomps over the other. So if you have any questions, please stop by the VMware Genius Bar. We'll be happy to answer your questions then. I will actually be out in the hallway, since we have another session right up against the back of this one, to answer any of your questions. And if you would, please fill out a survey on your mobile device using the VMworld app. I would love to hear your feedback. And thank you very much. I appreciate it.